Welcome everyone, Math 103. We're working on section 5.5 today, factoring polynomials completely. Up till now, in a given section, we've been given one particular type of polynomial to factor. Now, we're going to be presented with any of these types, and we're going to have to determine the type and then apply the appropriate strategy. So, an additional challenge now. So take a look at the first page. We have a table of all the different types that we've seen so far, along with a procedure and an example. This information is also on the flashcards, and if you have not done so already, I recommend starting to work with those flashcards every day until the exam. What we're doing today is going to be the best prep for the exam, because what you're going to see on that exam is a bunch of random polynomials to factor in any given order, and you're going to have to do exactly what we're going to do today. So let's talk about this general factoring strategy. We're going to go through these 4 steps on all polynomials. Number 1, and this is very important, factor out any greatest common factor that is in that polynomial. And the reason this is so important is 1, it simplifies the polynomial for factoring, and 2, some of the techniques that we've learned will not work unless you take out that greatest common factor first. So, first step, always look for a greatest common factor to factor out. Number 2, before we can apply a strategy, we're going to need to know what type of polynomial we're dealing with. So let's identify the type. I'm not going to test you on the names or anything like that, but you're going to need to know which type it is so you can know which strategy to pick. And that leads us to number 3, use the appropriate strategy for that type of polynomial. And so we're going to factor it with that strategy. And then finally, number 4, we're going to be examining the factors that we get out after we're done and see if any of those factors can themselves be factored. So a first example demonstrates all of these different steps. 2x to the 4th power minus 32. This doesn't fit any of the special types that we've seen so far, but we do have a common factor here. We have 2 even numbers, so we know we can factor out a 2. So let's see what happens when we do that. Factor out a 2, we get x to the 4th power minus 32 divided by 2 is 16. So we get x to the 4th minus 16 inside the parentheses. Now that we factored out the GCF, what's left inside the parentheses is revealed to be difference of squares. We have an even exponent here, so that's a perfect square, and 16 is a perfect square, so difference of squares. So now we can apply the difference of squares factoring strategy to this polynomial inside the parentheses. The square root of x to the 4th, we're going to take that exponent divided by 2 to get 2, so we have x squared for a, and b is the square root of 16, or 4. Now using the difference of squares formula, that gives us x squared plus 4 and x squared minus 4. So now we've completed step 3. Now we need to go on to step 4 and see if any of these factors can be factored. Well, 2 can't be factored. Here we have sum of squares. Well, that's not one of our special formulas, so can't factor this. But here we have difference of squares, so we can factor this. And using the difference of squares formula, we get x plus 2x minus 2. So here's the totally factored form of 2x to the 4th minus 32. All right, your turn, number 1. Use the general factoring strategy, and let's go through this one. Let's just do number 1, and then we'll go on and do the rest. So for this one, we got x squared minus 4x. So we have a difference here. We got a 2-term polynomial. So if you look at this first page, a lot of the categorization we can do by the number of terms. The only one here that has 2 terms is difference of squares. Now, it could always be a GCF problem. Those could apply to any of them, any number of terms. But let's see if we have difference of squares here. So x squared, that's a perfect square because we have an even exponent. 4 is a perfect square, but x, that's to the first power. It has an odd exponent, so this is not difference of squares. So the only thing this could possibly be, since it's two-term polynomial and it's not difference of squares, is a GCF problem. So we're going to factor out the GCF. All right, we've got one x in both terms. We can factor out an x. That gives us x minus 4. And that's it. That's all we can do with that one. So that's a GCF problem. All right, now as you go through these, there's a bunch of different problems here. And I'm going to be demonstrating them periodically. So you go through these, and make sure you go through these steps. And see how much you can do this without referring to your notes at all. And then if you have to refer to your notes, then you'll know what you need to study for the exam. So go on to your turn number 2. So for 2, we've got a 4-term polynomial. Now if you look through the table, none of these are 4-term polynomials except for factoring by grouping. So if you ever see a 4-term polynomial, it's going to be one of two things. It's going to be a GCF problem, or it's going to be factoring by grouping, or maybe a combination of the two. With this one, we do not have a greatest common factor. So we don't have x's in all 4 terms, and we don't have numbers other than 1 in all 4 terms. So no GCF to factor out. But we can do factoring by grouping. So with grouping, we're going to do the first 2 terms separately from the second 2 terms. First 2, we can factor out an x. So we get x times x plus 4. And over here, we can factor out the common variable, which is a y. So make sure you put the sign in between here, plus y times x plus 4, and there's our matching binomial. So you know we've done it correctly if you get a matching binomial. All right, now we're going to factor out that matching binomial, x plus 4, and what remains, x plus y, is the other binomial. So x plus 4 times x plus y. And with all problems like this, we should always FOIL, just make sure we factored correctly. So x times x is x squared, x times y is xy, 4 times x is 4x, and 4 times y is 4y. So we get all 4 terms. Your turn number 3. So we've got a 2-term polynomial, so it has to either be GCF or difference of squares. We have no common factors between those 2 terms, so this has to be difference of squares. As it turns out, we got a perfect square in x squared and a perfect square in 25. So difference of squares it is. A is the square root of x squared, which is x, and b is the square root of 25, which is 5. So using the difference of squares formula, we got x plus 5 times x minus 5. Your turn number 4. X squared plus 10x plus 7. So looking through the list, we've got several options for 3-term polynomials. We got perfect square trinomial, we got a factorable trinomial with a equals 1, and a factorable trinomial with a not equal to 1. Well, if you look at the coefficient on the x squared term, it's clearly not 1, so it's not going to be a factorable trinomial with a equal to 1. So this has to be either a perfect square trinomial or a factorable trinomial with a not equal to 1. All right, is it a perfect square trinomial? Well, 3 and 7 are not perfect squares, so it's not that. So this is one we're going to handle using the AC method. All right, A is 3, B is 10, and C is 7. So A times C is 3 times 7, or 21. All right, now we'll break up 21. into factors and see which of those pairs of factors will add together to get 10. So we got 1 and 21 and 3 and 7. So it has to be 3 and 7. So that's how we're going to break up that middle term. So we get 3x squared plus 3x plus 7x plus 7. Now we can factor out a 3x from the first two terms. So we start our factoring by grouping. Take out that 3x and get x plus 1. And now over here we can factor out a 7 and get x plus 1. So there's our matching binomials. Now we complete the factoring by grouping by factoring x plus 1 out. And we get 3x plus 7 for the other binomial. Your turn, number 5. So we have another 3-term polynomial. So it's going to be one of those 3 types we just talked about. Now, you can use different techniques for this one. You can either use the perfect square trinomial technique, so we've got a perfect square here, and this does indeed turn out to be a perfect square trinomial. Or you can just use the a equals 1 technique. Either one is fine, they both work. So I'm going to use the perfect square trinomial technique, where we find a by taking the square root of x squared to get x, and b is the square root of 25 to get 5. And I'm just going to do a quick check here to make sure that 2ab is the middle term. So we got 2 times x times 5, and that is 10x, so that matches. So we plug it into the formula, we get x plus 5 squared. Number 6. X squared plus 9x plus 8. All right, 8 is not a perfect square, so this is not a perfect square trinomial. And the coefficient on the x squared term is 1, so this is a equals 1 trinomial. So this one, we want to take 8, break it up into its factors. We got 1 and 9, and 2 and 4. 1 and 8, 1 and 8, 2 and 4. And we want the pair that equals 9 when we add them together, so that is 1 and 8. So those are the two numbers that go inside the parentheses. We get x plus 1 times x plus 8. Number 7. Got a 4-term polynomial, so this is going to be factoring by grouping. I'm going to look for a GCF, but we have no x's over here, no coefficients other than 1 over here, so nothing we can factor out. So we'll start with factoring by grouping. So the first two, we can factor out x squared. And get x plus 2 inside the parentheses. Then over here, we have a common factor of 25 between those two. So I'm going to factor out 25 and get x plus 2. So that gives us x plus 2 times x squared minus 25. So that completes step 3. Now we're on step 4. If possible, factor the result. So x plus 2, that cannot be factored, but here we have difference of squares. So if I take the square root of x squared, I get x. Take the square root of 25, we get 5. So there's a and b. So the factored form will be x plus 2, x plus 5, x minus 5. It's easy to forget about steps 1 and step 4. Make sure you're examining all the factors when you get done to see if any of them are factorable. Number 8. So two-term polynomial, see if we can factor anything out. We've got 81 and 4. No common factors exist between 81 and 4. So there's no GCF to factor out to begin with. Let's see what we got. We got a two-term polynomial. It could be difference of squares. 4 is a perfect square. X squared is a perfect square. And 81 is a perfect square. So it is indeed difference of squares. So let's find A by taking the square root of 4x squared. That gives us 2x. And then B is the square root of 81, which is 9. Plugging those into the difference of squares formula, we got 2x plus 9 times 2x minus 9. Number 9. Four x squared minus 20x minus 96. Now this looks like an a does not equal 1 trinomial. And you might be able to get it to work with that technique, but if you do, you're going to get factors at the end that need to be factored anyway. And the whole thing is going to be way harder. So let's make this easier by doing step 1 and factoring out the greatest common factor. 4 is a divisor of 4, 20, and 96, so we can factor out 4. And then we get x squared minus 5x minus 24. Now we have a regular old a equals 1 trinomial inside the parentheses. So this is going to be a lot easier to work with. Now we need to take negative 24 and find the factors that add together to equal negative 5. So we could have negative 24 and 1, negative 12 and 2, negative 8 and 3. All right, there's our pair, negative 8 and 3. Now make sure you keep that 4. Now our two binomials are using these two numbers, x minus 8 times x plus 3. So factoring out that GCF in the first step made that problem much, much easier. Number 10. So this one looks like a does not equal 1 trinomial. If we try to multiply together 18 and 60, we're going to get a gigantic number to factor. So we don't want to do that. So instead, we're going to factor out a 3. 3 is a common factor of 18, 21, and 60. So that gives us 6x squared minus 7x minus 20. Now we still have an a does not equal 1 trinomial, but this one will be much easier to work with because we have the smaller numbers. So I'm going to start by multiplying a times c using these values. 6 times negative 20 is negative 120. Now we're going to look at factors of negative 120 that add together to equal 7. And that'll be this pair, negative 15 and 8. So we're going to split up this middle term using negative 15 and 8. So that will give us 3 times 6x squared minus 15x plus 8x minus 20. Now we can factor this by grouping. And here we've got a common factor between 6 and 15 of 3. So we'll factor out 3x, we get 2x minus 5. And over here we can factor out a 4. And you get 2x minus 5. So there's our matching binomials. Keep that 3 on the outside. 2x minus 5, and then 3x plus 4. That brings us to your turn number 11. All right, so we've got a common factor here. These are all divisible by 5, so we can factor out a 5 and get 4x squared plus 12x plus 9. Now inside the parentheses, we could factor this using our AC method. There's going to be a much easier way if you recognize your perfect squares. 4 is a perfect square, x squared is a perfect square, 9 is a perfect square. So this may very well be a perfect square trinomial. Let's check it out. I'm going to find a by taking the square root of 4x squared. And that is 2x. B is the square root of 9, which is 3. Checking the middle term, 2ab is 2 times 2x times 3, which is 12x. So that matches the middle term, so this is a perfect square trinomial. All right, we've got a and b, so then we've got the positive version because we're adding the middle term. So that is 2x plus 3 squared. So much easier than the AC version. Your turn, number 12. So for this one, we got 2 terms, so we need to check for difference of squares. We've got an even exponent here, so this is a perfect square. 16 is a perfect square, so we do have difference of squares. So a is going to be the square root of x to the 4th, which is x squared, and b is the square root of 16, and that's 4. So factoring, we get x squared plus 4 and x squared minus 4. Now don't forget about step 4. If possible, factor the result. X squared minus 4, that's another difference of squares. So that gives us x squared plus 4. And square root of x squared is x, square root of 4 is 2. So a is x and b is 2. So that is x plus 2 times x minus 2. Your turn, number 13. So we have a 4-term polynomial here. So it's going to be factoring by grouping, if it's anything. But let's simplify it down first. We've got common factor of 2. All these numbers are even. So let's factor out that 2 first. And now it'll be a little easier to do the factoring by grouping. If we did the factoring by grouping first, we're going to get a factor in the end that's going to have a 2 that needs to be factored out anyway. So we might as well just do it in the beginning. All right, factoring out these 2, we can factor out x squared and get x plus 5. Then over here, we can factor out an 8 and get our matching binomial x plus 5. All right, now completing the factoring by grouping, x plus 5 and x squared plus 8. Your turn, number 14. So with this one, we've got at least 2 x's in each term, so we can factor out x squared. And between the numbers, we have a common factor of 13. So let's factor out 13x squared. And there's our GCF. That gives us x to the 4th plus 2x squared minus 3. Now with this one, we're going to have to get a little crafty. This is kind of an extra credit problem. You won't see one like this on your exam, but it's a good technique to know, especially if you're going to go on to 104. So we've got something that kind of looks like a quadratic here, because we have this x to the 4th term, which is double the exponent of what we have in the middle term, and then we got a constant term over here. So what if I created a new variable and replaced something with it? I'm going to create a new variable and make it equal to this middle variable. So y equals x squared. And now I'm going to replace these things with y's instead. I can keep this x out here because we're going to convert back when we're done anyway. All right, so if y is x squared, we need y squared to equal x to the 4th. So that is y squared. Plus 2y, replace the x squared with y here, minus 3. And now we've got a regular old quadratic we can factor. So let's do that. Let's go 13x squared. This is a equals 1 trinomial. We need 2 numbers to multiply to get negative 3 and add to get 2. So that's going to be 3 and negative 1. So that gives us y plus 3 times y minus 1. But when we factored this thing, we didn't want some expression with y's in it. We want something with x's in it. So now we need to replace it back. So wherever I see a y, I'm going to put an x squared back. So we get 13x squared times x squared plus 3 times x squared minus 1. So a very challenging one there, more of a 104 style problem. All right, so make sure when you're practicing, go through all 4 of these steps. And like I said, this is going to be the best prep for the exam because a bunch of random factoring problems, that's what you're going to see. All right, everybody, go practice.